Alright, let's have a look at problem 416, partition equal subset sum. So for this problem and in the current video, we're going to share a simple method called set and check method. So actually this problem can be solved by other methods too, such as backtracking and such as 0-1 knapsack dynamic programming. So with that said, let me first go through the statement of the problem, and then we explain the method and share the code. So the statement is as follows. So given a non-empty array called nums containing only positive integers, so we are required to find if the array can be partitioned into two subsets such that the sum of the elements in both subsets is equal. So let's look at one example. So in example 1, so we have 1, 5, 11, and 5. So the sum of the nums is 22. So if we can partition the nums into two equal sums, so the sum should be 11. So we can pick 11 as one part and 1, 5, 5 as another part. So this return is true. So here the subset is different from the set in mathematics, because in set we do not allow repetitions, right? So here you can understand that we partition the nums into two parts, and the two parts have equal sum. So this is example 1. So let's also look at example 2. So in example 2, the sum of the nums is 11. So 11 is an odd number, so we cannot make the task of partitioning the nums into two parts with equal sum. So the return is false here. So the constraint about the problem is the following. The length of nums is less or equal than 200. So it's not a very large number. So the nums I has a range is greater or equal than 1, less or equal than 100. So in other words, strictly positive and bounded above by 100. So with that said, let's look at the method in the current video. So the method we're going to use, we call it set abstract data structure and check method. So we have actually used this same method or idea, solved quite a number of other problems. So here is another practice. So I would see this current problem is actually exactly the same as Leetcode problem 494 after proper formulations. So the only difference is the format of returns. So in Leetcode 494, we are required to return the number of possibilities, and here we are going to return a Boolean variable, right? So in such sense, so this problem is easier than Leetcode 494. So with that said, let me share the idea here. So here we first check some special cases. For example, if the sum of nums is even, or if the length is an odd number also. Yeah, so if that's the case, so we cannot do the partition for sure. So otherwise, we compute the half of the sum, and then we are going to try to find that number or construct that number. For example, here in the nums, we want to partition the nums into two parts, and each part has a sum equals 11. So that's the initialization for the set. We want to see 11. And then we are going to do a linear scan of the nums. So for the first one, we see if we can form 11. So originally it had 11 in the want to see set. So once we examine 1, so we haven't seen 11. So we are going to use the 11 minus 1 to get a 10. Then we update this want to see. We get 11 add 10. So in the following steps, if we see a 10, so it says that we can make this number 11. So otherwise we continue. So when we enter step 1, so step 1 we have a number that is 5. So 5 is not 10 or 11, right? So we continue the procedure to build up numbers. So we use 10 and 11 minus 5 respectively. So we get 5 and 6. So if in the following steps we see 5 and 6, we are done, right? So then we enter step 2. In step 2, we see 11 directly. It means, oh, this 11 is in the 1 to C set. Oh, we are done. So this returns true. So actually, if the third one is another 5, it's also okay, right? Because it means that we can make 11. So this is the simple procedure. Actually, I would say this is a sort of modification of the dictionary and check method for problem 494. But it's just sort of in a reverse way. So with that said, I'm going to share the code. But before we do that, it's encouraged that you have a look at these two solutions. So these are the corresponding links for the two methods to problem 494. So now let's work on the current problem. So first step, we're going to track the information and do a edge cases check. So I'm going to check the length of nums and also check the sum of nums. Then what I want to do is, for safety, I will first check the edge cases. For example, if n equals 1, we cannot do partition anymore. Or s modulo 2 is not 0, then we're going to return false. Right, this is the routine. So next, I'm going to use the set and check procedure. Set and check. So this is also standard up to now, right? We have practiced quite a number of problems following the same line of ideas. So for this, I'm going to initialize a set called 1 to C. Initially, what we want to see is s integer division by 2, right? If we make this number out of the nums list, we're done. We're going to return true. Otherwise, we're going to return false. So basically, it's just a linear traversal. So for num, so let me use x in order to distinguish the num and its plural form nums. For x in nums, then if x in 1 to C, meaning that we can make this half sum, so we're done. So we're going to return true. Otherwise, we're going to iterate for the current state of 1 to C. So for that purpose, I want to initialize a new set called new 1 to C, just for convenience. So what we want to do is for target in 1 to C. So if target is greater or equal than x, then we can make another number. So that is new 1 to C. I'm going to add another number we can make, that is target minus x, right? So with that said, we're going to update the state of the 1 to C set. 1 to C basically is a unit of the new 1 to C. So once this is done, we're going to return false. In other words, if in the procedure we have made the half sum, that is s over 2, we have already returned true. Otherwise, we're going to return false. So let's first have a check for the special case. So here, x in 1 to C, the variable 1 to C. Let me change this one. Yeah. So it passes the first example. So now let's do a generic case check. it passes the generic case. So I would say we can use this method partially due to the constraint. The length of the number is very small, less or equal than 200. And the method is sort of standard. So here in the set and check part, we're writing in a reverse way. Actually, we can write in another direction. We can start from empty set, and then if we see a number nums, we're going to make a new number by adding the number to the elements in the set, and then we scan again if we found that number, or if we see half sum, we are going to return true, otherwise we return false. That's also a good choice. So I would encourage you to have a try in the other direction, right? So here, in short, in the 1 to C, we have the target first, that is S/2, and then we shrink this number and try to check if we can make in the process. What I want to encourage you to see is that we initialize a empty set, and then when you traverse the nums, you build new numbers, and then if you check if the S/2 is in the set, you return true, and otherwise you return false. So that's about it for this video and for this solution. Thank you very much.